Hi, in this video, we are going to look at the concept of toppling versus sliding. And this is a continuation of the statics series that we were doing. Basically, the first section in our mechanics course, which is about statics. So let's start by looking at a couple of problems. The first question is a JE 2000 problem. So it goes like this. This is a block and the length here is L and there is a force applied like this, capital F. This is a cubical block of side L which rests on a rough horizontal surface with coefficient of friction mu for the surface. A horizontal force F is applied as shown if the coefficient of friction is sufficiently high so that the question gives that friction is sufficiently high so that the block does not slide before toppling. Does not slide before toppling. We have to find out the minimum force, F minimum, required to topple the block. This is J2000. Okay, so this is a cube and the friction from the ground is such that it does not slide before it is toppling. So what does that mean? That means that the block was stationary before it toppled, right? We have to find out how much minimum force we must apply so that it starts toppling, right? Now, in order to approach this problem, we will first mark the center of mass of the cube, which will be through which the gravity force acts. So let's say mg acts through this point C, and obviously this distance is L by 2, right? Now, if you think about it, right now the cube is being balanced by the ground, and you can say the force applied by the ground will be the reaction force, and right now it is acting through the whole body, and we can say that there are two reaction forces. For example, you can approximate the whole reaction force or normal force from the ground in terms of two forces. One is here R1 and one is here R2. These are the forces at the two edges. Obviously, there are forces everywhere, but we are approximating it with these two reaction forces. In equilibrium, you have to say that R1 plus R2 must be equal to mg. That is the vertical forces, and friction is acting backward. So F must be equal to small f, right? This is the force equilibrium, right? Also, you must have that the torque of all the forces should be zero about its center of mass. So right now, the torque of all the forces should be zero about the center of mass. So we'll say the torque would be calculated as F times L by 2 plus R1 times L by 2 minus R2 times L by 2 and plus small f times L by 2, right, is equal to 0. This is the torque balancing equation according to our diagram currently, right? If the two reaction forces from the edges are like this, R1 and R2, and friction is acting this way, capital F is acting in the forward direction, this is the force balancing, this is the torque balancing equations, right? Now what happens is when toppling starts happening, the body starts basically turning and it loses contact with the left end. This point, the contact is lost. That is the point when toppling starts happening. The contact is maintained here, and basically rotation is going to happen about this point, right? And since it loses contact here, in the time when toppling happens, we can say that left end is above the ground, so reaction force R1 is 0, right? Reaction force R1 is 0. And now we put this R1 is equal to 0 in all of these equations, right? All these three equations, the force balance equation and the torque balance equation. What we get is R2 should be equal to mg, capital F should be same as F. And from here we get R1 is 0 and you get F plus F is R2. F plus F is R2. So basically R2 is equal to 2F, right? So F must be R2 is equal to 2F is coming and R2 is also mg. So F must be mg by 2 then, right? So you easily get that F must be equal to R2 by 2 or mg by 2, right? So what have we learned from this problem? That before toppling happened, all the forces were balanced, all the torques were balanced, and the reaction forces were from both the ends. But at the moment when toppling starts, you will lose contact with one end, and therefore only reaction force will be from the forward end. R2 will keep existing, but R1 will become 0. If you put that in the original equations, you will get the answer. Here the answer is capital F minimum should be mg by 2 and then you can topple the block, right? We will look at more cases to understand this idea of toppling better. So the next problem is this one. Question 2. There is a rectangular block. I will draw the diagram. This is a rectangular block. The width here is W. The height is H. And there is a force that is acting on the block. The force is being applied at a height of y, okay? And it is on the ground. The coefficient of friction is mu on the ground. We have to figure out basically when the block will topple, when will it slide. Basically analyze the situation, right? So understand when it slides, when it topples. This is the setup. And obviously we know that friction will be acting backward like this, right? Okay. So the forces acting on the block are the weight at its center of mass. So I will mark its center of mass here. This distance is obviously h by 2 and this distance is w by 2 and the weight is mg. The weight is acting at the center of mass. Friction force F is acting from the ground, which is backward, and normal force is acting from the ground, which is upward, right? Now, usually we mark normal force like this here, but you will realize that when we do the toppling condition, again the left end will lose contact and the normal force will actually start acting from here. So we will mark that later from that point, right? Now, what we have to say here is if you do the force balancing, we know that the normal force must balance the mg. There are no other vertical forces, it's just n is equal to mg, right? Now, if the block topples, it will have a shape somewhat like this, and it will topple about this point, right? It will lose contact here and it will topple about this point. So I will draw my normal force like this, my friction like this, my weight will still be acting from the center, and my force is still acting at that point, which is at a height y, right? So basically, at this instant, normal force will pass through this rightmost end and it will create a clockwise torque, right? So actually it is more difficult to analyze when you tilt the rectangle. What I will do is I will do the special case like this, where I will draw normal force here, friction like this, mg like this, and F like this. So this is the special case which is about to topple, right? So in this situation, what is the equations that we can write, right? It's about to topple, and what we can say is, again, normal force will be equal to mg as before, but this time the torque is just zero. Like Technically, the torque of the force F is greater than the torque of the normal force, right? If you calculate the torque about this point B, let's label this point B. So let's write the equations for all the torques, right? So we'll write it here. F times Y and minus mg times W by 2. These are the two torques, right? F times Y minus mg times W by 2. This is the torque, and if it is greater than 0, then toppling happens. Toppling happens. Because then the torque about B is non-zero and the body has to turn. Right? So the condition for toppling is coming out to be YF is greater than mgW by 2. Right? And let's think about when it slides. Right? This is the condition for toppling. Now let's think about when it will slide. So sliding will happen when the force F is bigger than the horizontal friction small f, right? So if F is bigger than small f, which is mu mg, if F is bigger than mu mg, then sliding happens, right? So what we can say is toppling happens when F is greater than mg W by 2y. This was the condition for toppling, and this is the condition for sliding, right? Now, obviously, now we can decide which will happen first, right? So, whichever value f must exceed mu mg or f must exceed mg into W by 2y, whichever happens first, that is what is going to happen. Like if mu mg, if mu mg is lesser than mg into W by 2y, or mu is less than W by 2y, right? Then f will be greater than mu mg. So sliding will happen first. Sliding happens first. So basically the conclusion is if mu is less than W by 2y, sliding will happen first. And if mu is greater than W by 2y, toppling happens first. It is pretty straightforward to understand why this is the case. The reason is that the friction can only stop the body from sliding till the force applied is lesser than the maximum value of its static friction. If the force applied is greater than the static friction maximum value, then sliding starts happening. And similarly, toppling can be stopped, or toppling will happen when the torque about the point B is greater than 0. So from both of these, we get a condition of the external force. And once you realize what the external force must be greater than in order for either of sliding or toppling to happen, you can compare and see which one will happen first. That is the basic idea here. Now let's move on to another problem. We will analyze the situation in different cases. So in this problem, we have an inclined plane. Inclined plane, there is a cylinder of radius r and mass mg. Mg force will obviously act like this. The incline is having angle theta. The coefficient of kinetic friction mu k is given. Coefficient of kinetic friction is given as mu between the surface and the cylinder. Now the question is being asked, where should a force be acting on the cylinder, capital F? At what distance above the inclined plane, what distance d, so that the cylinder slides up the plane without rotation? Where should F be applied so that the cylinder slides up the plane without rotation. Okay. So in this particular question, you have to understand what it means to slide up the plane without rotation. So if you think about it, the forces acting on the cylinder are this F force. There is normal force from the inclined plane on the cylinder. There is gravity and there is friction. So if you were trying to slide the force, the cylinder upward, friction will try to act backwards like this F, right? Now, if there is supposed to be no rotation, what does that mean? Basically, no rotation will happen if the torque about the center point is zero, right? Only if the torque about the center is zero will there be no rotation, correct? So then capital F cannot act through the line joining the center. Capital F must create a torque about the center because definitely friction is creating a torque about the center. So what we have to say is if this distance is d, then line of action of the force is like this. This distance is d minus r, right? This distance is d minus r. So we have to balance the torque. So we have to say if torque of F is F times d minus r is a clockwise torque and friction is basically also a clockwise torque, right? So basically the total sum of the torque should be equal to 0, right? Plus friction times r should be equal to 0, which means that Rf should be equal to F times r minus t. So this is one equation that we have, which basically gives us the value of d because we get F times r minus F times d. So F times d is equal to r F minus small f. So d is equal to r F minus small f by f, right? So basically d is equal to r times 1 minus f by f. And if you think of the f is mu mg cos theta. Why is f mu mg cos theta? Because normal force is mg cos theta. And friction kinetic will be mu mg cos theta. So the distance d should be r into 1 minus mu mg cos theta by f. So you realize that my figure is slightly mistaken because the distance d is less than the radius. So it has to be below the center line. Then only it will create an anti-clockwise torque because friction's torque is definitely clockwise. And the two torques have to be cancelled in order to slide without rotation. If there is a net torque, then obviously it cannot have no rotation, right? So you have to understand that here. So we are balancing torques to cancel the rotation, and after that it is over basically. Let's look at another problem. This problem was basically asked in JEE 2020 mains. So here we have a steps type of situation, and then there is a sphere. There is a sphere like this, or a uniform cylinder. Uniform cylinder of mass m, radius r, is supposed to be pulled over the step, and the step height is a. This is the height of the step, and a is less than r. It is supposed to be pulled over the step by applying a force at its center, which is perpendicular to the plane through the axis of the cylinder on the edge of the step. So basically, the figure is shown like this. The force has to be applied like this, capital. This is 90 degrees. Okay. This is the radius. And you have to pull this cylinder over the step. The question is asking for the minimum force required. What is the minimum force required to pull the cylinder over the step? Right? So basically, right now the cylinder is at contact here also, and it is at contact here also, right? But when you pull it over the step, this is like toppling, you lose contact at C. You will lose contact at C when it is about to be pulled up. About to be pulled up. At that moment, you will lose contact at C. So basically, if you draw the forces and all, mg will act like this constantly, but the normal force will vanish here. The only normal force will be like this perpendicular here, right? This is the normal force and this is the F. There are three forces acting at this moment. Capital F, mg and normal force, because you lose contact at C, so we cannot ascribe a normal force there, right? Okay. Now, what is the net torque of of on the cylinder about point P? The net torque about point P, net torque about P must be greater than equal to 0 for toppling to happen or for it to be able to be pulled up about point P. It has to turn about point P, then only it can go up, right? So the torque about point P, if you calculate, the torque of the force F is going to be F times R, and torque of the normal force is 0. We just have to calculate the torque of mg, right? The torque of mg would be basically mg times this distance, right? And that would be anti-clockwise torque. So this perpendicular distance we have to find. And now think about it. This height is A. So this much is what? This much is A minus R minus A, right? And this is R. So we can calculate this distance by Pythagoras theorem. So the distance is actually root over R square minus R minus A whole square. That is the distance here. And the torque of mg would be negative mg times root over R square minus R minus A whole square, right? These are the two torques. They are in opposing sense because F tries to turn it in this way, clockwise way, and mg tries to turn it in anti-clockwise way. If the total torque is greater than equal to 0, toppling will happen and you can pull it up. The normal force does not create any torque because it passes through the point P. Okay? So my condition basically becomes F is greater than equal to mg by R root over R square minus R minus A whole square. Right? That becomes my final condition for toppling here. Or this can be rather called as rolling over a step. Right? Okay. So that was this particular problem. And more or less we have covered the idea of sliding and toppling. Hopefully you have understood what happens in toppling. The main idea to realize is that in toppling the body will lose contact through other points and it will be turning about one single point. The normal forces have to act through that point, and the torque about that point has to be greater than equal to 0 for toppling. So when you have a horizontal surface, the body has two options. It could slide or it could topple. And you have to calculate accordingly which one will happen, depending on whether the force applied is greater than the sliding friction or whether it is having enough torque to make it turn about the point, right? So hopefully you have understood this concept. This has appeared in problems before, so therefore I wanted to mention it. In the next video, we'll be looking at some more advanced problems in statics and equilibrium. And once we do that, we'll conclude this section. Uh, the next section obviously is Newton's laws of motion. So there are a lot of problems and a lot of JE questions that we'll be analyzing over the next few videos. So stay tuned, keep watching. If you like the content, please subscribe to the channel and share it with your friends. Your support is absolutely important for me. So I'll see you next time.